So today's session will be on triple products. So when we talk about triple products, we start with the scalar triple product. Okay. So say for example you have three vectors, okay? Three vectors A, B, C. Okay. So the STP, the scalar triple product of these three vectors is defined as A vector dot B vector cross C vector. Okay. This particular expression is called as the scalar triple product of the three vectors. Okay. So this is going to be a determinant basically, right? It's a determinant. So what kind of a determinant? A 3 cross 3, okay? A 3 cross 3 determinant. On the top usually we will have, so if you are taking B cross C, the components of B will fill the second row, components of C will fill the third row, right? The first row will be filled by IJK. So since you are taking the dot product with A, the components of A will fill the first row. Okay, so it will be AX, AY, AZ, BX, BY, BZ, CX, CY, CZ. Okay. And since it is a determinant, the properties of determinant will follow for this. Okay. From the properties of determinant, you can also say that this particular expression is going to be equivalent to B vector dot C vector cross A vector, and this is again going to be equal to C vector dot A vector cross B vector. Okay. So we are going to look at this one. So in this place the components of B is going to fill the first row, components of C in the second row, components of A in the third row. Okay. But how it is equivalent to this one? Cyclic, yes. There is a cyclic order follow. So here, when we look at this as a determinant, okay, you look at this as a determinant. So what kind of a change I must do over here to get the determinant expression of this scalar dot product? So B was in the first row, here B is in the second row. So what I have to do? I interchange. Now A is in the second row. Now you interchange R2 and R3. Okay. Since it is an even number of interchanges, there is no change of sign. You get the same determinant value as that of the original one. Okay. So both are same. And likewise you can get the equivalent for this also. Okay. You can make a note of it. And also very importantly, also it follows a cyclic order. Okay. So if you take A as this one, A, B, C, okay, so it will always follow a cyclic order. Okay. A dot B cross C equals B dot C cross A equals C dot A cross B. Okay. and we usually represent this scalar triple product like this. Okay, so this is how it is represented as. So ABC confined inside a square bracket. Okay, we will go for the next. So we have the three vectors, alpha and beta are integers. You are given a dot b is -1, b dot c is 10. What is a cross b dot c is asked. You can simply make use of the conditions, right? So the first objective is to find what is alpha and beta. Then we will have a clear picture of A, B, C vectors, and you can just substitute it over there and find the value. So any answers? So A vector dot B vector was given as -1, so we just take the dot product. What do we get? 3 minus alpha beta minus alpha beta equals -1. In that case I can say alpha beta is going to be 2. B dot C is 10, so B vector dot C vector is 10. Minus 3 alpha minus 2 beta minus alpha equal to 10. Minus 4 alpha minus 2 beta equal to 10. 2 alpha plus beta is equal to -5. So looking at this combination, so since they are saying alpha and beta are integers, you can make a guess. To make a guess, alpha is -2, beta -1. We can make a guess because alpha beta are integers. So alpha equal to -2, beta equal to -1. Okay, so it satisfies this also. -4 -1 -5. -2 into -1, 2. That's all. So we just have to find what is A cross B dot C. So what is A cross B dot C? So you can just put the A terms in the first row. A components 1 minus alpha. Alpha is -2, so 2. Beta is -1. Then 3 -2, beta, right? 3 -1, 2. C vector is going to be 2 -2, 1. Okay, it's fun. So what do we have? -1 plus 4 -2 into 3 minus 4 -1 into -6 plus 2. So what is the answer? 9. Answer is 9. Okay. It's a very simple question, direct question. The only thing you need to be you need to focus is you have to make sure that the right components are written in the respective rows. Okay, depending on this one. Okay. Okay, properties of box product. Again, this is just another way of looking at the determinants. -1/2 and -2 will not satisfy. Not an integer, right? Alpha and beta are integers nu kuduthirukanga. Yes. See, this is just again the properties of the determinant. So you know already A vector component is going to fill the first row, B vector is components are the second row, C vector components third row. So this is basically right, multiplying a number in the first row, L in the first row, M in the second row, N in the third row. Now you can take all of them outside the determinant, right? So L into M into N into the original determinant A, B, C. Okay, box product. Again here also. So this is the property 5 we studied already, right? So if the first row is a binomial, you can divide it into two individual determinants, right? Sum of two determinants, right? So this is again the property 5. So this is where you are getting binomials on the first row and binomials on the second row also. Okay. So if you expand this determinant using property 5, in the first row you will get two determinants, and each of the two determinant will have the binomial in the second row, and for each of the determinant you will get again two determinants. Okay. So 2 plus 2, 4. Okay. Yes, this is the cyclic property we know already. Follows the cyclic property. We saw it in the first slide, right? Follows the cyclic property. They are just writing it in terms of the box. Okay, the boxes. That's all. So always remember. So you don't have to remember this, but you remember this one. Okay, remember this one. So A, B, C, right, should always be like this. Okay, so you can write A dot B cross C equal to B vector dot C cross A equal to C vector dot A cross B. Okay, so if you want to write it as a box product, in the first one you will be having A, B, C. Second one can be written as B, C, A. Okay, the third one can be written as C, A, B. Okay, so we get all these things. Okay, and that will be negative of BAC. Why? Because you are interchanging one row. Okay, one pair of row, only one time you are doing that. Okay, so that's why it's minus BAC. Okay, so we are just studying the properties of determinants again, okay, in a different manner. Do you want me to explain this? It's clear, right? This one you want how it is the case? No, these two are different ones. Okay, what they are saying is, you can break this into 4 box products. You can make this into 8 box products. You can break this into 8 box products. Okay. So how we will do that? So we have this. Okay. First we will expand using the first row. Okay. So that will give me A vector, C vector plus D vector, E vector plus B vector plus C vector plus D vector, E vector. Okay, now you split the second row now. Okay, expand the second row. Vector, E vector plus A vector, D vector, E vector plus B vector, C vector, E vector plus B vector, D vector, E vector. Okay, so we have 4 box products. Okay, same as the determinants. Yes, coplanarity condition we know already. A dot B cross C is 0. Okay, coplanarity condition. Understandable here, right? So when you take a plane and if B and C are in one single plane, okay, if A is also in the same plane, then I'll just take this as B, because we are using a right hand thumb rule, right? So B vector, C vector. So use a right hand thumb rule. So that means your normal vector will be like this. N vector is nothing but B vector cross C vector. Now B vector cross C vector dot A vector gives me 0, because this vector and A vector is going to be perpendicular to each other. Okay, that's why ABC box product is 0. Okay, show that the 4 points whose position vectors are coplanar. So whenever they are giving you points, you make them as vectors. So 4 points are given, make 3 vectors and use the coplanarity condition. Okay. If you take ABC or ABCD, okay. So given the position vectors, okay, not just some random vectors, position vectors of 4 points. So we need to form vectors using these position vectors. So AB vector, what will be AB vector? 10 minus 19 plus 7 minus 12. There is no K here, so minus 4. So we have AB vector. BC vector minus 16. C vector minus B vector, okay, remember OC vector minus OB vector, final minus initial. So minus 16, 22, J cap, minus 6 plus 4, minus 2, okay. And then we have CD vector, 2 minus 5 minus 3 minus 8, 10 plus 6, 16. Okay. So we have some common factors here. We'll just write, I will just take the common factor outside. So 2 times of 5 minus 6 minus 2 and 2 times of minus 8, 11 minus 1, 2 times of 1 minus 4, 8. And now since they are asking us to show that the points are coplanar, we don't have to take these values, right? We can just form a determinant only using these 3. Okay, if the box product of these 3 vectors are 0, then it is done, right? We have proved. So box product of these 3 vectors, so you can just take the topmost one, 5 minus 6 minus 2 components, minus 8, 11 minus 1, 1 minus 4, 8. Okay, basically you can take it in any way you want. Okay, you can take it in any way you want, because we are only trying to prove that it is 0. Okay, the objective was to show that it is 0. Even though you are changing the rows here, only positive negative sign change will happen. Okay, that's not going to affect anything. So is it becoming 0? Any columns are proportional, any rows are proportional? Okay, simply expand. 88 plus 88 minus 4, 84 plus 6 into minus 64 plus 1 minus 2, 32 minus 11. Is it becoming 0? 0 only. Did you find? Okay. So 22, 21, 21 2s are 42, minus 42. Now we can take 21 as a common factor also, and you can see 21 into 5 times of 4, 21 3s are 63, 6 into minus 3 minus 2, yes 0, 20 minus 18 minus 2, 0. Okay, 21 was a common factor, okay, for 84, 63 and 21. Okay. Yes, you can do this. Yes, everyone click. No, this is just for attendance. I didn't start. So use the coplanarity conditions. Given that ABC are coplanar, so what is the non-zero vector? That means you may get a 0 vector. So then the non-zero vector A cross C is. So coplanar is given. So ABC is 0. So we have the determinant 1, 2, 4, 1 lambda 4, 2, 4 lambda square minus 1 equal to 0. For what values of lambda this is happening? So after expansion you will be getting what? Lambda cube minus lambda minus 16 minus 2 times of lambda square minus 1 minus 8 plus 4 times of 4 minus 2 lambda. So we are getting a cubic polynomial, and yes, you can also get that point, right? You will get a cubic polynomial because the product of the diagonal elements is forming a cubic. Okay. So whenever you want to see what type of a polynomial the determinant is forming, just take the degree of the product of the elements in the diagonal. Okay, elements diagonal elements எல்லாம் ப்ராடக்ட் பண்ணிட்டு ஒரு எக்ஸ்பிரஷன் வரும், அதோட டிகிரி என்னவோ அதுதான் வந்துட்டு உங்களுக்கு இந்த டிட்டர்மினன்ட் எக்ஸ்பேண்ட் பண்ணும்போது ஒரு எக்ஸ்பிரஷன் வரும்ல அதோட டிகிரி. ஓகே, ரெண்டுமே ஒன்று தான். ஓகே, so what do we have? Lambda cube minus 16 plus 18 minus 16 plus 16 plus 18, right? Minus 16 plus 16 gets cancelled, so plus 18 minus lambda minus 8 lambda minus 9 lambda. That's all, right? Minus 2 lambda square. So we have. Okay, did everyone got this? Okay, now you can solve. So whenever you are given a cubic polynomial, do a trial and error with some integers 0, 1, 2, 3 or 0, minus 1, minus 2, minus 3. Okay, do a trial and error. Okay. Because even if you find one factor, then you can easily simplify the other. Okay, the remaining will be a quadratic factor. So what does is something working here? Lambda equal to 2. If you put lambda equal to 2, it is working, right? 9 2s are 18, 18 minus 18 0, 4 2s are 8, 8 minus 8 0. So lambda equal to 2 is a root. Okay, so we found one root here. So lambda equal to 2. Okay, 0 cannot come. Minus 1. Minus 1 is also not possible. 3. Whether 3 is working? Okay. 3 cube 27. 9 3s are 27. Cancels. 27 minus 27. Yes, 3 works. So lambda equal to 3 minus 3 also. Yes. So we found all the 3 roots. Okay. So lambda equals 2, 3 and minus 3. So we have 3 solutions for this. And they are asking us to find a non-zero vector A cross C. So that you can find. Yes, completed. Done. Okay. Start. So everyone is having clickers, right? Yes, very good. D is the answer. So did all the values work? I think only one of them would have worked, right? Only one of them would have worked. Okay. So you just have to plug in these values over here. Okay, you can just plug in the values and check whether you are getting A cross C as 0 or non-zero. If it is 0, in that case you cannot take. Okay, because they have specified it is non-zero vector. Okay. So lambda equal to 2 was working, right? Lambda equal to 2 was working. This is again from the determinant condition. You might have seen this as a remark in the determinants. Okay? Does anyone remember? You might have seen this as a remark. Okay. So whenever this is the case, A plus B, B plus C, C plus A in the box product, you can say 2 times of the box product ABC. Okay? This one is very simple to interpret. Okay, so if you interpret this using the determinants, okay, have the determinants in your mind. So how the interpretation is? So this is nothing but, so we already know what is the box product. It will be AX, AY, AZ, BX, BY, BZ, CX, CY, CZ dot L cross M, I, J, K, L, L1, L2, L3. Okay, I'll just take this as LX, LX, LY, LZ, MX, MY, MZ. Now, how do you take the dot product? You can also multiply the rows as well. Okay, corresponding rows can also be multiplied. So what is the first resulting element will be? So if I consider this as if you consider this as R1, what did we do here? We are talking about the products, right? Yes. So here you can multiply the first rows of these two. If you multiply the first row of these two, that becomes the A11 element in the place 1 1, right? We know. So ax I cap plus ay j cap plus az k cap is what? A vector. Then I need the element in the first row, second column. First row into this one. Okay. So ax, no, sorry. Bx by bz dot ijk. Okay. Bx by bz dot ijk. So that gives me B vector. And again cx cy cz dot ijk. C vector. Then again the same case, ax ay az into lx ly lz, that gives me the 2 1, okay, element in 2 1. So that is nothing but a vector dot l vector. Okay, so likewise you can get all these things, b vector dot l vector, c vector dot l vector, and then what can you say, a vector dot m vector, b vector dot m vector, c vector dot m vector. Okay, that's how it comes. Okay. Okay, if you find this way of multiplication difficult, do the matrix multiplication. Okay, do the matrix multiplication, but it will not be visible over here. So first take the transpose of this and then do the matrix multiplication, then it will be easier to understand. Okay, another determinant at the value maraporadilla. So you can take the even if you take the transpose, the determinant value will not change. So you can take the transpose and do the dot product, and while you are doing the dot product, do the matrix multiplication. Okay, instead of row, do row column, the as usual way, in the way we do the matrix multiplication, do in that way, you will get the same thing again. Okay, so say for, you can imagine, right, ijk lx ly lz mx my mz. So ijk will be over here. So ijk dot this one, a vector, ijk dot this the b vector, ijk dot c vector, adhe mari inga lx ly lz, a dot l, b dot m, b dot l, c dot l. Okay, and here also a dot m, b dot m, c dot l. Okay, like that. So after taking the transpose I am saying. Okay. And similarly here also the same concept applies here. Okay. So basically you can remember like this, like ABC dot ABC. So you can just do the dot products of this. First put it in the first row, then do the dot product of BA, BB, BC and C dot A, C dot B, C dot C, put it in the third row. Okay. That. So again these things are something which is something you can easily get it. Okay, you don't have to memorize. Only properties of determinant theriyum, you know how determinants will work. So from there you can get this result directly. Okay, you don't have to memorize this. No need of rote memorization. So here the multiplication scheme was like this. Okay, I followed something like this. So this and this. Okay, like row multiplication. If you take the transpose and do the matrix multiplication, the same thing will come. Okay. Okay, I will give a hint. So what do you get when you do this? What do you get when you do this? We already studied, right? So it's going to be a cap dot a cap dot b cap, a cap dot c cap, and similarly b cap dot a cap, b cap dot b cap, b cap dot c cap, and c cap dot a cap, c cap dot b cap, c cap dot c cap. Okay. So this is also something you can do. Okay. Evaluate the determinant. You already have the values, right? A dot b, b dot c, Square. They are asking you only the magnitude of this, not the square. Take the root. Okay. That's all. So you will be having 1, 1 by 2, 1 by 2, 1 by 2, 1, 1 by 2, 1 by 2, 1 by 2, 1. Okay. Okay. 2 minutes of time. Start. So you did A dot B cross C like modulus of A into modulus of B cross C. Okay. So that you can take it like modulus of B into modulus of C sin theta. And theta you already know, theta was 60 degree. Yes, that works. Yes, very good. B is the answer. So, but still, if you take A dot B cross C, you need to know the angle between A and B cross C, right? You know the angle between B and C, A and B, A and C, but how do you find the angle between A and B cross C? Perpendicular to B and C. Perpendicular to B and C, A will be inclined in any angle, no? A can be inclined in any angle, right? How do we say that is also 60? That's not 60. Okay, it will be perpendicular to B and C. But since you are doing A dot B cross C, you need to know the angle between A and B cross C, right? But we don't have any information on that. We cannot find it, right? Of course, we can find, but so in that case, so here you are taking like B, C, and you are taking the A vector also, A cap. Okay, like this. Say for example, this looking like this. So B cross C. So you know this is 60 degree. B and A is also 60 degree. C and A is also 60 degree. B cross C. If you do B cross C. So C cross B will be on the top. B cross C will become negative, right? Goes down. But how do you say this angle is 60 degree? I am asking. Like what will be the angle I am asking? 30. Yes, because B and A are being inclined on 60 degree. So the remaining angle will be 30. So you did 30. You didn't complete. You can complete, right?
B and C are the same side, sir.
B and C is okay. B and C is done.
It makes angle 30 degree with A.
It makes angle 30 degree with A. So let us try that. So in that case I can simply say modulus of A vector into modulus of B into modulus of C vector. This is something we know. You say sin 60, right? But these two are getting inclined like cos 30. So everything is 1. Sin 60 into cos 30. Sorry. Yes, 1. 1. Sin 60 is root 3 by 2. Cos 30 is 1 by 2. No, root 3 by 2 again. Both are root 3 by 2. So, A can be in the plane. No, I am not considering A as in the plane itself.
Pyramidal shape form.
Like pyramid only it forms. A cannot be in the same plane, right?
Pyramidal shape form.
A cannot be in the same plane. A has to be outside the plane only. So BC can be considered in one plane. A has to be protruding outside. Okay, something like this. So then only you can say CA is 60, BC is 60, AB is 60. Like that. We cannot take A and B, right? We have to take the angle made by the vector A with the plane containing B and C, and that is not equal to the angle made by the A vector with B alone. Right? Both are different. Yes, that was the point. So in that case we don't know what is A dot B cross C. Okay, so this way you cannot do. Okay, I think it is clear, right? The angle made by the line with the plane, that is different from saying the angle made by a line with another line lying in the same plane. Both are different. Right? Both are different. So that's the reason this is not working. Right? So it doesn't work.
Even if you use this method, we are getting root 3 by 2,
1 by root 2 only. 1 by root 2 only. Answer is 1 by root 2. Okay? Don't get confused. Is everyone getting 1 by root 2? Yes. Get 1 by root 2. So it is not working. Okay? I am just specifying it. This does not work.